These are the test statistic for testing various parameters of the population. This text will be posted as a PDF in the description box. Okay. If the problem is to test the proportion based on one large sample, this is the test statistic, P minus capital P divided by square root of PQ by N. The null hypothesis to be tested here is capital P equal to P naught. Okay. If the problem is to test the difference of proportions to compare two different proportions, the null hypothesis is H naught such that P1 equal to P2, and this is the test statistic. This denominator is the standard error of the statistic. This PQ, square root of PQ by N is the standard error of P. Square root of PQ into 1 by N1 plus 1 by N2 is the standard error of P1 minus P2. Okay. If the problem is to test the mean based on large samples, this is the null hypothesis, and the test statistic is x bar minus mu by sigma by square root of N follows Z distribution. Okay. The standard error of x bar is sigma by square root of N. Standard error is in the denominator. And when the problem is to test the means to compare the two different means, the null hypothesis is this and the test statistic is this, and this is for the test done on large samples. Okay. Modulus of x bar minus y bar divided by square root of sigma 1 square by n1 plus sigma 2 square n2. This is the standard error of x bar minus y bar. This is the standard error of x bar. See, actually the statistic t minus expected value of the statistic, that becomes 0 in this case and in this case. So this is your t and this is standard error of t. This is your t, this is expected value of t, and this is the standard error of t. Okay, fine. Now when the problem is to test the mean based on a single sample which is small in size, the degrees of freedom is n minus 1, and this is the formula. This is the sample variance. Okay. And when the problem is to compare the means based on two independent samples, right? Two independent small samples, the test statistic is t is equal to x bar minus y bar divided by s into square root of 1 by n plus 1 by n2. And this is called parity test. When you are testing based on two dependent samples of small size, the degrees of freedom is n minus 1, and you use this paired t test. Okay, this is actually the sample variance, and this is S, that is summation, square root of summation xi minus x bar the whole square by n, okay, which is a biased estimator of mu. This capital S is square root of summation x minus x bar the whole square divided by n minus 1 and the root of it. Okay, variance when it is tested here, the null hypothesis is mu1 equal to mu2, and here again the null hypothesis is mu1 equal to mu2. Here you are testing the variance, right? So sigma square equal to sigma naught square, and the chi-square test should be used, and sigma 1 square equal to sigma 2 square. You are comparing the variances. Variance ratio test, which is also called F test, is used. Okay, so let us talk something about the critical region and acceptance region. See, when the test is two-sided, the critical region of size alpha will be at both the sides, alpha by 2, alpha by 2. And the area here is 1 minus alpha. These two are rejection regions, and this is the acceptance region. When the test is two-sided, you will have rejection region at both the tails. And suppose that it is a Z test, you call this as Z alpha by 2, and this is minus Z alpha by 2. Okay. So, how will you mathematically express the critical region? It is probability of modulus Z greater than or equal to Z alpha by 2. This is actually the critical region, that is equal to alpha by 2 plus alpha by 2 is alpha. Okay. So modulus of z greater than or equal to z alpha by 2 is alpha means what? Z is greater than or equal to z alpha by 2 and minus z is also greater than or equal to z alpha by 2. Right? That is, z is greater than or equal to z alpha by 2 and multiply by minus 1, it becomes less than or equal to. So you read this statement. The statement says probability that z is greater than z alpha by 2 and probability that z is less than minus z alpha by 2 together it is equal to alpha by 2 plus alpha by 2 alpha. Clear? So how will you define this critical region? You can define like this, okay, which means the area after z alpha by 2 and the area just before minus z alpha by 2 together is alpha. Right? This is how you should define this. So otherwise you can say modulus of z greater than or equal to z alpha by 2 is alpha. Fine? Okay, come here. Yours is a right-tailed test now. In the right-tailed test, the entire alpha will be here and this is 1 minus alpha. The critical region, that is the rejection region, will be in the right tail. Okay. How will you express it? Probability of, you need not have modulus of z now because you don't have any critical region in the left tail. So you just say, how will you call this value? This is z alpha. Probability of z greater than or equal to z alpha is alpha. This is how you define the critical region for a right tail test. Okay. And for a left tail test, your critical region will be here, whose size is alpha, and you call this is minus z alpha. So probability of z less than minus z alpha is alpha, or you can simply say probability of modulus z greater than z alpha is alpha. Right? Oh, fine. So here it is alpha. Okay. Now you may get questions based on this description of critical region. Now let us go to the questions for today's video. If x follows normal distribution with mean mu and variance sigma square, what is the distribution of x bar? X bar follows normal distribution with mean mu and variance sigma square by n. Option B is the correct answer. While testing the difference of means based on large samples, what is the standard error of x bar minus y bar? I told you the standard error, actually the formula for the test statistic is t minus expectation of t divided by standard error of t. For any statistic, the denominator contains the standard error. So for difference of means, what is the standard error? Root of sigma 1 square by n1 plus sigma 2 square by n2. So while testing the difference of means based on large samples, what is the standard error of x bar minus y bar? Option A is the correct answer. The null hypothesis, see this test statistic is for testing the mean. Okay. So what is the null hypothesis here? This is not the right answer because it talks about two populations. This is also not the right answer. Mu equal to mu naught is the right answer. The null hypothesis for testing chi square equal to ns square by sigma square. This is the test statistic. What would have been the null hypothesis? You will be testing the single variance. For two variances, f test is used. For two means, z test is used. For standard deviation, again based on large samples, you have a z test. The null hypothesis for testing f is equal to s1 square by s2 square is variance ratio test. Here you have to compare two variances. Okay, this cannot be the null hypothesis. This is also not the hypothesis for this test. Okay, and this is not the hypothesis for this test because this test is for comparing the variances. Okay, so the idea for this you have in this table. The idea for all these questions is there in this table. Okay, I have given the null hypothesis here and the corresponding test statistic. This will be posted as the PDF in the description box. Okay, now let us have some more questions. The equation which describes the critical region for the right-tailed test while testing the mean based on large sample. For testing mean based on large sample, Z test is used. Right? So, the test is right-tailed. So, the entire critical region will be in the right tail. And this is 1 minus alpha. How do you call this ordinate value? You call it as Z alpha. So, how will you define the critical region? It is probability of Z. Z values are plotted here, right, on this axis. Z is greater than Z alpha is alpha. So, option A is the correct answer. The critical region for the left tail test while testing the mean based on large sample. The test is left-sided, right? Left-sided means you will have the critical region here. This value is minus Z alpha because if this is Z alpha, this is minus Z alpha. Okay. So, how will you define the critical region? Let us check. Can you say that probability of Z less than Z alpha is alpha? No. Can you say that probability of modulus Z less than Z alpha is alpha? Modulus of Z less than Z alpha is alpha. Probability of Z less than minus Z alpha is alpha. This is more appropriate, right? So, option C is more appropriate. Let us have one more question. The critical region for two-tailed test while testing the mean based on large sample is. Two-tailed test means you will have critical regions at both the tails. And here the area will be alpha by 2 and here again it will be alpha by 2. So this ordinate you represent it as Z alpha by 2 and this will be minus Z alpha by 2. Okay. You place the suffix based on the area, right? So this is Z alpha by 2 and this is minus Z alpha by 2. Now, what is the critical region? Probability that Z is greater than Z alpha by 2 is alpha by 2. Modulus Z greater than or equal to Z alpha by 2 is alpha by 2. This is the correct critical region. Okay.